Welcome to the Calculus Spring Semester Review. We'll be going over a bunch of integration concepts because that's what we have done this semester. So we'll get started here with some things that, now that we've done harder stuff, should hopefully be pretty easy. For instance, these first two are power rule, and that's all we have to do. Like, we don't have to do anything else except just do the power rule. So when I use the power rule for something with a fraction as an exponent, I just have to make sure that I add with a common denominator. So if I add 1 to 4/3, I'm really adding 3 over 3. And that gives me 7/3 for my exponent. So that is what I'm going to divide by, because that's how the power rule works. If I do 28/3 divided by 7/3, in case you don't remember how that works, it's like you're flipping the 7/3 and multiplying, and so the 3's will cancel, and you'll have to do 28 divided by 7, which is 4. Essentially, because our denominators are the same, they should cancel out, and then we should just be able to divide the numerators. When the denominators are not the same, then that makes it a little bit more complicated. It makes it to where you actually have to think about this. So, since they were the same, we just divided 28 and 7 and got 4. So this is 4x to the 7/3. And then we'll have minus, because that's what that next sign thing there is. Then we want to do the same thing for these other two, but we're going to add 4 over 4, because that's the common denominator there, which gives us 9/4 to divide by. So since they're both over 4, we just need to do 27 divided by 9, which is 3. So minus 3x to the 9/4. And then we're going to add 5 over 5. So that gives us 8/5, and that divides 32 divided by 8 is 4x to the 8/5. Since this is an indefinite integral, this is where we put a plus c at the end, because we cannot tell if there is supposed to be some number here, and that's why we put the plus c. The rule is that you either are going to put a plus c or you're going to find a number answer. And so since we didn't actually have numbers to plug in here to find a number answer, it needs a plus c. The next problem has negative exponents, but that's okay, because we'll still add 1. We do need to be careful when we add 1 here and make sure we actually add it and don't subtract it. When I add 1, I get -1, and I need to divide by -1. Then I add 1 to the -4 and get -3, so I'm going to divide by -3. Now, we'll have a plus c, but we also want to simplify this. Not only do we want to simplify it, but we want to move the x's down to the bottom, because in math we generally like to have positive exponents instead of negative exponents, as long as it's a reasonable thing to do. So the 5 and the -1 will make -5, but that x moves down to the bottom. The 5 doesn't move because the 5 has a positive 1 for its exponent, not this -1. It's only affecting x there. And then we'll do -9 divided by -3, which is plus, and then we'll have 3 on top and x cubed on the bottom, and then plus c. So this right here is our answer. Now these next two are not the power rule. You can try to do the power rule on number 3, but you should end up with an issue, because if we move this up to the top and say that it's 2x to -1, and we try to add a power to that, we get 0 and divide by 0, and you can't divide by 0, which is why the power rule doesn't work. And so you either, as a calculus student, need to have this memorized, that the integral with an x, just an x on bottom to the first power, is the natural log, or if you're allowed to use a formula sheet, then you'd have that on your formula sheet. The 2 that's on top just goes in front, so this is 2 natural log of x plus c. On this next one, we have e to the x is the important part here, and again, either with a formula sheet or just having it memorized, the integral of e to the x is e to the x. And so that -4 just stays in front. And so those are pretty easy as long as you recognize them for what they are. We've got a few more. We've got a trig function for number 5, that what we're looking for, or what we should have memorized, is what is the integral of cosecant x cotangent x. The integral of that is cosecant x, and it makes it switch signs. So since this was a negative, it switches to a positive cosecant, and we'll also need the 4. So 4 cosecant x plus c. Can't remember if I put the plus c on the last two. Make sure that you... Okay, I did on one and not the other. Plus c. Because anytime we don't get a number answer, we should have a plus c when we're integrating. These next three are some special ones that, again, you either have to have memorized or on a formula sheet. These are the inverse trig functions, and so we just need to figure out which one is which. And so when there's not a square root on the bottom and it's 1 plus x squared, that's inverse tangent. And it's just inverse tangent of x because this is x squared and 1, and that's what our formula looks like. On 7, we do have a square root, and we don't have an x outside the square root, so this is inverse sine. Basically, if you were allowed a formula sheet, you'd be playing a matching game here to see which one of these it is. And so that leaves us with secant for this last one. And secant x maybe should have absolute value bars around the x. I'm not going to be super picky about that, but apparently that's a thing. So, I mean, go figure. Now, let's do some definite integrals. This is where we use whatever rule we need to, like the power rule, or change it to a logarithm or whatever. But then we also plug in the numbers. We plug the top number in first, and then do minus what we get when we plug in the second number. So here with the power rule, this would be negative 2x cubed over 3 plus 8x squared over 2 minus 10x. We're not going to put plus c because we want to plug these numbers in. So we're going to plug in 3. And then we're going to minus what we get when we plug in 2. Now, a lot of the problems you can have with plugging things like this in hopefully shouldn't happen because we aren't plugging in negative numbers. So if you're allowed to use a calculator, then honestly, for them, even though it may feel frustrating, like the easiest way to not mess this up is to type it all in at once, exactly how it looks right now. The other way you can do it is just by separating it into different parts and either doing it on your calculator or by hand. I'm not going to go through and bore you with the details, but our answer for this is negative 8/3. Now, whenever I first did this problem, I was like, oh, that can't be right because it's negative. Because the things we've done most recently in our calc class, we couldn't have negative answers. And so I was so set in that mindset that I reworked the problem trying to figure out what I did wrong. But this isn't an area or volume problem. We're allowed to get an answer of negative 8/3, as weird as it might seem. So we also get a negative on 2 more of these, and that's fine. It's not a big deal. On 10, to integrate this, we need to move the x up to the top. And so that's going to give us negative 5x to the negative 2, which we are going to power rule. So we're going to add 1 and then divide. So that gives us negative 1 over negative 1 with the 5 still in front. And we're going to plug in 2 and 1. If you're doing this by hand, you definitely want to rewrite it as 5 over x to make it easier. If you're doing it in the calculator, you don't have to move the x down to the bottom. It doesn't really matter which way you do it, but if you're plugging it in, you get something that's pretty easy to do by hand. 5 halves minus 5 over 1. You could pretty easily get a common denominator or whatever and get negative 5 halves as your answer. These next two are not the power rule, just like what we had earlier. We have a logarithm and an exponential function. So on this one on 11, this just turns into negative 3 natural log of x with the x and absolute value bars, which will be important here because when we plug in these negative numbers, those absolute value bars, their job is to take the negative away. So when we first write it, we've got negative 3 natural log of negative 1 plus, because it's minus a negative, 3 natural log negative 3. And so you, at some point, either will just leave it or plug it into the calculator, depending on whether you're allowed to or not. And so the negatives go away. And so if you're plugging it into the calculator, don't put the negatives in there. Just type in -3 natural log of 1, close your parentheses, and then plus 3 natural log of 3. You should get 3.296 for your answer to that. And then on 12, the integral of -e to the x is just -e to the x. We're going to plug in 1, -2, so -e to the first minus a -e to the -2. Again, without your calculator, you could rewrite this and simplify it in some ways, but if you're allowed to just plug it into the calculator, you just find the e button, which is the second natural log button, and get -2.5829. After we did just simple integrals like this, hopefully you think they're simple, otherwise the rest of this will just get harder. We did u substitution, and so u substitution comes in whenever we have more than one thing basically happening, and where you could choose for something to be u, take the derivative of that, and have that appear basically somewhere else in our problem. And so what we want to pick for u is things inside of our parentheses or inside of our radical or on the bottom of our fraction. It should be the thing, it should have to do with like where your power is. Like here we have a fourth power outside of our parentheses. Here there's a third power outside. This is like a 1/2 power, which we'll have to change it to. And this is like, I don't know, it's like a big thing on the bottom. That one I think is the trickiest for me to relate to these other two, but hopefully it won't be so hard to spot it. So u is the inside of our parentheses, x cubed minus 5. And we're going to find du, which is the derivative of u, and that is a different kind of power rule. When we do the derivative, we multiply by our power and then subtract 1, which is the exact opposite of what we do when we integrate, which is what this squiggly symbol means. So the derivative of this is 3x squared. The du and the dx have to do with notation and things like that. Together, du and dx mean derivative, but what we're doing is we're saying that the rest of our problem, we're saying this is u, so we've got u to the fourth, but then we're saying here's 15x squared and dx. We have 3x squared and dx. Let's divide those, and when we do, we get 5, and our dx cancels out, but we're going to put a du instead because our letters are supposed to match. Now we can use the power rule for integrals, which means add a power and divide. So you get 5u to the 5th over 5, which we'll simplify to just be u to the 5th. And because it's just u to the 5th, we'll plug u back in and get x cubed minus 5 to the 5th. And since we're not finding a number answer, since there's no numbers to plug in, we just box it and say, voila, das is our answer. 14, u substitution again. This time our u will be what's in the parentheses on bottom. And so that means it is 3x cubed plus 4. Du is the derivative of that, which you multiply by the power and then subtract 1, so that's 9x squared. We are going to put u down here on the bottom, so u to the third power is on bottom, and then we look at what's on top here, and we divide 36x squared by 9x squared, and that's what we're going to put on top of our new fraction. So 36 divided by 9 is 4. And then it's going to change to du. Now the way we integrate this is by bringing the u up to the top and then doing the power rule. So we add a power and divide. And then we are going to simplify, like this is really going to be a negative with a 2 on top. We're going to move the u down to the bottom and make it be u squared on bottom. And either in the same step or a separate step, we're going to put u back in. So that our final answer should look like this with a plus c. 15, u is what's underneath the radical, so u equals x cubed plus 3. Du is 3x squared, dx. So we compare 6x squared and 3x squared. When we divide those, we get 2. So this is 2 square roots of u, or it'd be easier just to change it to u to the 1/2. And then we're going to add a power and divide, so that gives us u to the 3/2 divided by 3/2. Now you may be thinking to yourself, hey, how do I combine 2 over 3/2 into just like one thing? So the 2 on top is like 2 over 1, and the 3/2 on bottom we're going to flip up and make it be the reciprocal. So you'll see the 2's are both on top, so they don't cancel, which is what you probably wanted to have happen. Instead, we end up with 4/3, and so that will be 4/3, and u is x cubed plus 3 to the 3/2. You can do 4 over 3 or 4/3 in front. It doesn't really matter how you write that, as long as you have a 4 and a 3 in that order, one on top, one on bottom. So something like that is your answer. And then on 16, u is what's on bottom, but this time there wasn't an exponent, and so when there's not an exponent, like there's not something out here outside of our parentheses power-wise, this is going to be a natural log when we switch it, because we're going to do 30x to the 4th divided by 10x to the 4th, which is 3. So we get 3 over u, and that is 3 natural log of u, and we'll put absolute value bars around u and a plus c. Hardest part on those is remembering that that's natural log and not the power rule. So 17 and 18 are also u substitution. And so with these, for e, we want to make the exponent be what u equals. It says 3x to the 3rd plus 4th du is 9x squared dx. So we do 36x squared divided by 9x squared, which is 4. This is 4e to the u du, which is 4e to the u du. And so we can just put the u back. And some of these may be easy enough that you don't even have to write out the steps, as long as you understand the concept of taking the derivative and dividing whatever you have in front by it. On 18, this has trig functions, and u is going to equal what's inside of our trig functions. Fortunately, it's the same for both, otherwise this would not work out super well. So when I take the derivative, that's 8x cubed, which is exactly what's in front, so that's just going to go away completely. We're integrating secant u tangent u du, which the integral of secant u tangent u is secant. So again, that's either something you have to have memorized, or if your teacher lets you use a formula sheet, you can have it written on a formula sheet. And then don't forget your plus c. Now we're going to do u substitution and definite integrals. So we're adding that step of plugging in numbers. We start this off the same way with making it be 2x squared plus 1, which is what's in parentheses on bottom. We're going to take the derivative of that and get 4x, which means that this on top cancels out completely. And what we have is negative 1 over u squared right now. Now, 0 and negative 2 only work with x's, and so we can do this two different ways. One way is to go ahead and plug in 0 and negative 2 right here to find what they would be with respect to u. So that's 2 times 0 squared plus 1, which gives us 1, and 2 times negative 2 squared plus 1, which gives us, oh, I don't know, 9. So since u is 2x squared plus 1, and the 4x canceled, we have negative 1 over u squared, which I may have already had there and then erased for no reason. So we found the boundaries. The new boundaries are 1 and 9. Now, you may, like it's weird for the bottom number to be bigger. We can find the answer this way, or we could say, oh, if I switch these around, that changes the sign here to be positive. Either way you want to do it, you'll get the same answer, just as long as you have the negative on this one with them written this way, or if you don't have a negative on this one written this way, it doesn't matter which way you do it. So to prove that, I'll do it this way, and if you want to, you can do it the other way. We need to move this up to the top, so that's negative u to the negative 2, which is going to be negative u to the negative 1 over negative 1. That's what we're plugging 1 and 9 into. Those two negatives right here in front cancel out. This is really 1 over u. So we've got 1 over 1 minus 1 over 9, which gives us 8/9. On 20, same kind of deal. We've got u substitution to start us off here. U equals the inside of our parentheses, x squared plus 1. Du equals 2x. So we're going to do 6x divided by 2x, which is 3. And then u squared. Just like we did before, we're going to plug 1 in right here to find our new boundaries. So 1 squared plus 1 gives us 2, and 0 squared plus 1 gives us 1. So we're plugging in 1 and 2. We're going to power rule this. So that's 3u cubed over 3, which simplifies to just be u cubed. So 2 cubed minus 1 cubed, which equals 8 minus 1, which is 7. What a lovely answer. Now we're going to start getting into the more complicated stuff, like this next set of problems has to do with partial fraction decomposition. And so we start off just wanting to rewrite this broken up. We don't actually want to solve. And so remember that when you have something squared like this, where you have something linear that's squared, you have to do x and also x squared. Then we'll have to do x plus 1 and x plus 1 squared. All of these things, though, are linear. Some of them are being squared, but essentially the inside, if it helps to think of this like it's in parentheses, what's inside is linear. And so all of these just get one letter. And so since it's not on here, the other situation we had was if I had something like x squared plus 1, where the squared is with the inside with the actual x, that's when we would put like in 2 letters like this. That didn't happen on this. This isn't actually a part of this problem, but that's like an alternative situation we could have. On 22, this is actually more like what we were just doing, where we were just integrating using the power rule and logarithms and all that jazz. We were just doing it 3 different times. And so like this is just an x plus 1 on the bottom without a power, which means it's the natural log function. And so the 3 goes in front. Here we want to move this to the top and give it a negative exponent. We want to add a power and divide, and so that gives us 7x plus 1 to the negative 1 divided by negative 1. So that's negative 7 over x plus 1, because it was this. We got this, and then we're simplifying it. So that makes negative 7. Move the x plus 1 down to the bottom. And so then the same kind of thing is going to happen here. We're going to move the x cubed up to the top, and then add a power and divide. So that actually will not end up being a plus sign. We'll have 4x plus 1 to the negative 2 over negative 2, which gives us minus 2 over x plus 1 squared, plus c. Now, these are actually 2 partial fraction decomposition problems. So the way this works is that you take what's on bottom and you have to think about what are the possible denominators that could come together to make this denominator. And so this would just be splitting up into x plus 3 and x minus 2. Our next step is to pretend like we are getting common denominators. So we multiply this first fraction by x minus 2 and the second fraction by x plus 3. And then because now we are saying we have common denominators, we will drop the denominators. There's typically two different ways that you do this at this point. You either distribute a and b and then match up your x's and match up your numbers, or we can actually plug in some x's here strategically, like if I plug in 2 to all of the x's. That is helpful because 2 minus 2 is 0, and we'll cancel out everything there, including the a, which means that when we solve out the rest of this, we'll be able to figure out what b is. So like 6 times 2 is 12, minus 7 is 5, so 5 equals 5b. Divide both sides by 5, and you get b equals 1. We'll do the same thing, but now we'll plug in negative 3. The way you pick these numbers is you look at the inside of your parentheses and say, what would make this be 0 on the inside? You have to do them one at a time. You can't make them both 0 at the same time. And that seems like it would be bad even if we could. So now we're going to use negative 3 because it's going to make our other parentheses 0. So 6 times negative 3 minus 7 equals a times negative 3 minus 2 plus b times negative 3 plus 3. So this is negative 18 minus 7, which is negative 25, equals negative 5a. So we divide both sides by negative 5 and get 5. Now we finish this off by rewriting our fraction. This is 5 over x plus 3 and plus 1 over x minus 2. We're going to do the same thing on 24. 24 works a little bit differently though, because this is x minus 4 squared, which means we need an x minus 4 and an x minus 4 squared. Both of them just need a single letter on top. Now, a big mistake I see on problems like this is that people just want to flip-flop the denominators, but if I'm actually trying to get common denominators here, this first fraction just needs x minus 4 to get it to be x minus 4 squared, which is what we have for both of these fractions. A lot of people will try to multiply it by x minus 4 squared and multiply b by x minus 4, but then we would have x minus 4 cubed on the bottom, and that's not what's on the bottom on this side, so we don't actually end up getting the right answer. B does not need to be multiplied by anything. It already has the denominator we were wanting. So we drop our denominators. And then I'll show you the other way we do this, where it would be pretty easy if we just plugged in 4, and then we'd have to just pick another random number to plug in, and that would give us the other letter. But if I want to try the other way, just to remind you what it is, I distribute the a, and then I match up the x's, and I match up the numbers. So 3x goes with ax, and then negative 20 goes with the rest of this. The reason this is helpful, especially on this problem, is because in order for 3x to equal ax, then a has to be 3. And then in order over here for this to be equal, well, now that we know what a is, we can just plug it in. So we're doing negative 20 equals negative 12 plus b, so we need to add 12 to both sides. And we get negative 8 for b. So we rewrite our fraction 3 over x minus 4 minus 8, because it was a negative 8, over x minus 4 squared. Now we've got some good old integration by parts, which there is a formula that is involved here that is helpful to have. So it goes integral of u dv equals uv minus the integral of v du. You don't really have to worry about that part of the formula because I already gave you u and dv. That's how you figure out what u and dv are. Like u is the x part of this, which is right here in our formula. dv is the rest of it, which is here. Now we need to find du, which is the derivative of x, which is 1x. I mean just 1 dx. And we need to find the integral of e to the x, which is just e to the x. And then fill in this formula. So u is x, v is e to the x, minus the integral of v, which is e to the x, du, which is 1 dx. Now, what's important here is that e to the x times 1 dx is still just e to the x dx. And we can find the integral of e to the x really easily. Easily starts with an e. Never mind. It's just e to the x, and it's a minus because of the minus sign in front. And then we put our plus c, and then we box it, and then we're done. So then on this next one, they told us u and dv. Now, the derivative of natural log, and if you are allowed a formula sheet, you might think about putting this. The derivative of natural log is 1 over x dx. And then the integral of x will be the power rule, so x squared over 2. We're going to fill in our formula uv, so ln of x times x squared over 2 minus the integral of v times du. Now, this does not combine with the x that's in the natural log, and so all we can really do is move it in front if we want to, just to help us remember that separate. X squared over 2 times 1 over x, we have an x that will cancel on the top and the bottom. And then we can power rule this. So the front doesn't change. We will power rule, so we add a power and get x squared. If I divide by 2, and I'm already dividing by 2, so what we have basically is this. And so I have a 1/2 already, and I'm dividing by 2, which is like multiplying by a half. So together on bottom, that makes a 4. You could get a common denominator here if you wanted to, and put it all over 4, but that essentially is our answer. 27 wants us to find the derivative of this integral. Well, fortunately for us, taking the derivative of an integral cancels it out. All we've got to do is take this letter and switch it for our t's. So this is negative x squared plus 4x minus 1. Nothing else changes. All of the signs stay the same. All the numbers stay the same. It's supposed to be a really easy problem, but it is alluding to the fundamental theorem of calculus, which says that derivatives and integrals are opposites of each other. It says it in super fancy words, but that's the basic gist of it, is that these are opposite, and so they undo each other, kind of like squares and square roots undo each other. It's a fun time. On 28 and 29, we are solving some simple differential equations. So you just want to integrate both sides here, and that means bringing this x to the 5th up to the top as 2x to the negative 5th, and power ruling. Also, when we integrate dy over dx, we get y. So this is y equals 2x to the negative 4th over negative 4. And there's a plus c because we integrated. If we wanted to simplify some, 2 over negative 4 is a negative 1/2. And we're going to move the x down to the bottom to make it a positive 4 on bottom. So this would be our answer. Then on 29, no power on the bottom. This is a natural log, so we integrate. You may not be excited about natural logs, but you really should be because they require the least amount of effort. The only thing that makes them difficult is realizing, oh, I can't use the power rule on this because it's a -1, and so that means I have to change it to a natural log. Now we're going to find some particular solutions. So it starts the same way by integrating both sides, but what they're doing is they're giving us an x and a y so that we can plug in and find the c that goes with this problem. Did I put plus c on the last one? Yes. Good job, me. All right. So this is y equals, power rule here, we add a power and divide and get x squared. Power ruling 1 makes it have an x, then we put plus c. So they're telling us in the problem, that x is -1 and that y is 3, because this is the same kind of format that you see f of x equaling something, where the inside of the parentheses is x and then the other side is your y value, because it's what f of x equals. So we want to put 3 equals -1 squared plus -1 plus c. Then we want to solve this. So like this will be a +1. +1 minus 1 cancels. So c is 3, which means our function is y equals x squared plus x plus 3. Now we want to do the same thing, but on a problem that looks significantly more difficult. Now this moves up to the top when we integrate, and we do the power rule, so we get -x to -4 over -4. I think it's way easier to do this if you move the negative back down. You may not agree. That's fine. We're not the same people. We don't have to agree on these things. But the negatives do cancel out, and you would put 4x to the 4th on bottom. Now let's plug in a 2 for x and a 129 over 64 for y, which may seem like a terrible, terrible thing to have to plug in, but don't worry, this is all going to work out just fine. So the question here is, what is 1 over 4 times 2 to the 4th? So it's 1 over something. That would be 64 on bottom, which is good because that means we have common denominators. And like I always say, all you really need in life is common denominators anytime you're adding or subtracting fractions, and you'll know everything will be okay. So we want to subtract 1 over 64 from both sides to get rid of it. From the right, c will equal 128 over 64, which incidentally is 2. These problems are designed so that you'll get nice numbers, and so if you don't, that means you did something wrong. So we just now fill in a 2 where c was, and this right here is our answer. We've got some more differential equations to solve. Now these are trickier and a little bit longer and whatnot, and that's because we don't off the top of our head know what the integral of -1 over sine y is, and so we are going to cross multiply to start this off. And when cross multiplying here, we're going to have to decide where to put that negative. It doesn't matter which side you put it on, to be perfectly honest. Like you can put negative sine y dy equals 1 dx, or you can put the negative over with the 1. Like it really doesn't make a difference. Well, it may make a difference to how you feel about things, but it doesn't actually make a difference. Now we're ready to integrate. When I integrate negative sine y, I get cosine y. And when I integrate 1, I get x, and I'm going to put a plus c. Now to solve this for y, we do the inverse cosine of both sides. So that gives us y equals the inverse cosine of x plus c. And we're solved for y, so there's nothing else we can do. I'm sorry that I just like totally went through that on accident. That's kind of bad. But that's how you do that problem. They didn't give us any numbers to plug in, so that's why I didn't plug any numbers in. On this next one, we're going to cross multiply as well. And this one, the reason that you know for sure that you need to is because we want the y's to be on the same side. Otherwise, this doesn't really work out super well. So we'll do y squared dy equals x squared dx. And then integrate both sides. And both of these will require us to use the power rule. So this is y cubed over 3 equals x cubed over 3. We put plus c because we integrated. And in case you're like, well, why did we put it on that side and not the other side? It doesn't matter which side you put it on. You're allowed to put it on either side, but since we're solving for y, it makes it easier if we put it on the right side. We're going to times both sides by 3 to get rid of the 3's on bottom. And then we are going to cancel the 3's. So this is y cubed equals x cubed. And so if I distribute the 3 to the c, I can write 3c, but the idea is I didn't know what c was. I don't know what 3 times c is, so I can really just put c again. That may bother you, and if it does, I'm sorry, but that's how we do things. That's how we roll in the math world. We're going to cube root both sides to finish solving for y, and believe it or not, you cannot actually cancel out these cubes because of the plus c. And so this right here would be our answer that we are looking for. Now let's do some slope fields. We are going to plug in x and y into this function and then draw that as a slope. So since there's only a y here, all these y's across that are 2 will have the same slope. 2 squared is 4. So we're going to draw a really, really close to vertical positive slope that they're supposed to all look like they're about the same here. At y equals 1, that's 1 squared, so we draw a positive 1 for our slope. At 0, 0 squared is 0, and so that's a horizontal slope. You are filling in all the dots and all of the points on the x and y axis. When I plug in negative 1 and I square it, I get positive 1 again. Don't let that squared fool you. It takes away those negatives. And then negative 2 squared is a positive 4, so it's a steeper slope than what we just had. This is what our slope field looks like. On 35, we have x and y, so we'll have to be more careful. 0, 0, I'm just going to leave blank. You could convince somebody if you wanted to that it's 0 or undefined, or even that it's 1. Like there's a mathematical possibility of that all 3 of those answers being argued for. So I'm just going to leave it blank. So the rest of this though, like 1 over 1 is easy. So 1 comma 1 gives you a slope of positive 1, and 2 over 2 would give you a slope of positive 1. So would negative 1 over 1 and negative 2 over negative 2. Then the other direction, we'd get negative answers to this same situation. That's a really bad slope. Sorry, that's also bad. Pretend those are straight lines. So that is because they cancel but have a negative, like when you do negative 1 over 1. From here, it may get a little trickier. When x is 0, which is on the y-axis, that makes the top 0, which makes it a horizontal line. And then whenever y is 0, which is the x-axis, that will give us vertical lines because they're undefined. Because a skier on these slopes would have an undefined amount of fun. Then the rest of them, you're just going to have to probably plug in, like 2 comma 1 is 2 over 1, which is 2. 1 comma 2 is 1 over 2, which is a half. And then these will be the same but the opposite direction. And then down here, negative 2 over negative 1 is positive 2. And then negative 1 over negative 2 is positive 1/2. And then these go the other direction. So there are your slope fields. Now let's do some exponential growth and decay. We have an investment that we want to have triple. They give us an interest rate compounded continuously. We want to know how long it takes. And so the formula for this is a of t equals a0 e to the rt. And we want to fill this in. And we know that originally we've got 16,000 and that our interest rate is 6.5, so that's 0.065. We're trying to find t, so there must be some way for us to figure out a of t. So the key is that we have 16,000 that we're wanting to triple. So triple of 16,000 is 48,000. To solve this, we are going to divide by 16,000 because right now our priority is to get e by itself. When we do that, we should get 3, otherwise we did not triple correctly. To get rid of this e, we're going to take the natural log of both sides, gives us natural log of 3, and it cancels out the e on the right so that it's just 0.065t. We divide both sides by 0.065. And ln of 3 divided by 0.065, if we round to the nearest hundredth like it asks us to, is 16.90 years. And that's our answer. This is exponential decay. We are wanting to know how long it'll take to decay to 30% of its original amount, which in our formula they tell us is 200. And we're solving for t. So we can do this a couple different ways. One way involves us finding 30% of 200, which means we do 0.3 times 200. And that gives us 60. And so you can say, well, that means, sorry, I couldn't find my cursor, 60 equals 200e to the negative 0.09t. Divide both sides by 200. So the other way we could have done this would be to take the 200 out and put 0.3 on the left, because in order for us to decay to 30%, these numbers, when we divided, had to be 0.3. So whichever way you want to do that is fine. Then we take the natural log of both sides and divide by negative 0.09. So we do ln of 0.3 divided by negative 0.09, and that gives us, if we round to the nearest hundredth, which is 2 decimal places, 13.38 years. Newton's law of cooling has a formula. It's kind of on the complicated side. And you may want to, if you're allowed a formula sheet, you may want to make a note of what the different letters mean. T is our temperature at time little t. Ts is the temperature of the surrounding area. T0 is our initial temperature. K is a constant that we have to start off finding. In the problem, they said that it starts at 150, so that's T0. Our freezer, which we're putting it in, is 0, which makes it the surrounding temperature. After 10 minutes, so that's time, which is little t, the temperature is 80, which is big T. Whatever the last thing they tell you is, that's what you're going to save for the next part. So we need to do 80 minus 0 equals 150 minus 0 e to the negative k times 10. We're going to solve this for k, kind of like how we solved for t just a little bit ago. This is going to be 80 and 150, as we're subtracting 0, so we're going to divide 150 on both sides, which will give us 0.53 equals e to the negative 10k. We'll take the natural log of both sides and then divide by negative 10. And so that gives us k, which the more decimals you write down here, the better, but at least write down 3, if not more. This is 0.06286. And now that we know what k is, we're going to re-plug in and figure out what they actually asked us. They actually want to know what the temperature will be after 15 minutes. And so we're trying to find big T. Almost everything stays the same, except that now we know what k is. And we're switching our time from 10 minutes to 15 minutes. So we just need to plug this in. If this wasn't minus 0, we'd have to add whatever this is over to the other side. Since it's minus 0, we won't have to. But that means that T equals 58 degrees, since it asks us to round to the nearest degree. Now, the rest of this review is what we've done most recently. And so, hopefully you remember it the best. We're going to graph what we have. Like, we have the line y equals 2. we have the lines x equals -3 and x equals -1. And then I skipped over the part that's actually more tricky, which is the 2 over x squared. So you can plug this into y equals on your calculator and use the table of values. You can plug in some numbers yourself. It's kind of whatever. But what we get should look something vaguely like this. And I drew it on both sides, but I really only need the left side. We want what's in between all 4 of these things, which is this part inside right here. And these actually are exactly the same as some problems on our previous review, which was an accident. So I probably shouldn't have told you that, but it's fine. Our boundaries for this, they actually gave us the -3 and the -1 for our x's. That's what is stopping us on the left and the right. We kind of have a formula for this that we want to do the top of our region minus the bottom. So the top part of this is the line 2, and we want to subtract the bottom, which is the 2 over x squared part of this. So to integrate this, we are going to power rule. This is 2x. Remember, we bring this up to the top and make it be x to the -2. We add a power and divide. And we want to plug in -1 and -3. And so I feel pretty confident in you being able to do this. You can use your calculator. You can do it in your head. Either way, you should get 8/3 as your answer. If you have problems getting 8/3, it's probably a calculator issue, and that's something you should ask a friend about, or a teacher, or somebody that would be helpful in knowing this. On 40, to graph this, we have a line that starts at 1 and then has a negative slope. This time they didn't give us boundaries, and so our boundaries are going to be where these intersect, which means that you want to make sure to draw your graph well so that you can tell where they intersect. This parabola has a point at 3, 0. There's an intersection point. And there's an intersection point. And we want to shade the region that's in between them, which is right here, and we want to find the area of that. So the x values are what we need here. And so our boundaries are at 2 and 5. Our function that's on top is the parabola, because the top part of our region, and we want to subtract the line. And so we want to make sure that we distribute this negative. And then we can add like terms. We can do that in the same step if we want to. Like this is a plus x, which makes it be 7x instead of 6x. And this is a -1, which makes it -10. We want to power rule, which we've been doing a lot of actually recently. A lot of power ruling. And then we want to plug in 5 and 2. And again, you can probably do this. You plug in the 5 and find that part if you want to, minus what you get when you plug in 2. You should get 9/2 when you're done. That one also shouldn't be too bad to plug in since they're both positive numbers. Hopefully you'll do okay with that. 41 is another area between two curves, even though the instructions aren't above it. This is the one that will suck because there are two different areas that we have to find. Okay, that's kind of a ridiculous drawing on my part. I don't know what to say, except that I should probably start that over. Maybe I'll start with the other one. Our cubic function has a point at -2, 2. And at -1, I think it's like -1.5. 0, 0. 1, 3.5. 2, 6. I don't have any clue what 3 is, but at 4, it's down at -4. And so if you look at your cubic function, you should be able to tell. Now, the line that we've got starts at 0, 0 and goes up 1 over 1 and down 1 over 1. And so it's these two areas right here are what we're going to find. So the first area has x value boundaries of -2 and 0. The top of the shaded region for this first part is the line, which is -x. And so then we need to subtract the cubic function from it. We're going to add to that because these are two separate areas, and so to find the total area, you would add. The integral, it starts at 0 and ends at an x value of 4. And it's flip-flopped. Now the cubic function's on top and the line is on bottom. So we're going to start with -x cubed over 2 plus x squared plus 3x. We're going to subtract the line, which is -x. We can distribute our negatives and add like terms, and then we will integrate, and then we will plug in numbers. So -2 and 0. This will be positive x cubed over 2 and -x squared minus 4x. This will be the opposite of that, -x cubed over 2 plus x squared plus 4x. The power rule gives us x to the 4th over, if I divide by 4 and it's already got a 2 on bottom, that's an 8 altogether, minus x cubed over 3 minus 4x squared over 2, which simplifies to be 2x squared. And we're going to plug in 0 and -2. And then -x to the 4th over 8 plus x cubed over 3 plus 4x squared over 2. I'm going to plug in 4 and 0. Now when you plug these in, because of the zeros we've got, that actually makes it easier. So you'll have 0 minus, and then you'll have what you get when you plug in -2. Plus, you'll plug in 4, and then have -0. So what you really need to do is figure out what you get from this first part when you plug in -2, and then change its sign. And then figure out what you get when you plug in 4 and don't change its sign. Add those two numbers together, and that will be your answer. If you do that correctly, you should get 74/3. Volume with disks. This is a slightly separate situation. Our formula for this is pi, and then our integral, and we take our function and we square it. So y equals 0 is one of our lines, and that's also what we're rotating around, is our x-axis. X equals 1 is a boundary. A cubic function, you go to math to find that button, and it should look like this. All we want is this little part that's in between all three of those things. And so that means that our boundary is from 0 to 1. We're doing the cube root of x, and we're squaring it. Now this is tricky. What is the cube root of x if we square it? We've had a square root earlier in the review, and we said a square root turned into a 1/2 power. Well, this cube root turns into a 1/3 power. And so then if I want to square a 1/3, those multiply together, which would give us 2/3. So that's what we're going to integrate, is x to the 2/3 using the power rule. So we add a power and get 5/3. And we divide by that. And then plug in 1 and 0, which means that this is 3/5. Also, there's a pi that we need to keep track of. So this is 3/5 pi is our answer. Okay. 43. Also volume with this, but this time we're not rotating around the x-axis. We're rotating around y equals -1, which is down here. This is where we're rotating. It's also one of our boundaries, as well as x equals 4 is a boundary. And I put that on the wrong line. This is -1. And then we're going to draw our square root function. And so this in here is what we are trying to use. That's what we're rotating around the line y equals -1 to create a solid that we can find the volume of. And so our x values give us our boundaries, 0 and 4. And because of this axis, since it's -1, we want to do the opposite and add 1 to our function now that we're plugging it in. So we're not going to plug in square root of x minus 1. We're just going to plug in square root of x, which is awesome because squares and square roots cancel each other out as long as they're the only two things involved. So we're really trying to find the integral of x, which is a really easy power rule. X squared over 2. You plug in 4 and 0, and you get 8. I feel like you get 8. And then there's a pi, which who doesn't love pi? This next one is washers, and it looks really similar to start off with, maybe with the square root of x plus 1. And so at least that part, like graphing it, is similar, except it's up here at +1 instead of down there at -1. Then we've got this parabola that starts at 1. Now one thing is, it is super helpful if you draw your square root function well. That may have made it worse. I don't know. Let's find out. The parabola starts at 1 and goes up and over 1, but it curves out like it's concave up because it would hold water, whereas the square root function was concave down. And so when we do our formula, which is essentially top squared minus bottom squared, or outside squared minus inside squared, because it has to do with where we're rotating around, which is the x-axis. Well, the top function here is our square root function because it is the one that's curving out up above our region. So this is going to be pi from 0 to 1 of square root of x plus 1 squared. And we're going to subtract our other function, x squared plus 1 squared. And we're going to FOIL these out because it's not just as simple as saying what's square root of x squared and what's 1 squared. It's almost that simple, but there is an outer and inner term that happens whenever you actually write this out twice and try to FOIL it. Because you're essentially doing this right here. So you have to say my outside term is 1x and my inside term is 1x, and so together those make 2x. So this will be square root of x times square root of x, which is x, plus 2 square roots of x, plus 1 times 1, which is 1, minus, and we're going to FOIL this out as well. So that'll be x to the 4th plus 2x squared plus 1. Now what tends to happen here is when you distribute, at least something should cancel out. Maybe not as many things as you would like, but something should. And so in this case, the 1's cancel. But otherwise, we're stuck doing all of this still. 2 square roots of x, let's change to 2x to the 1/2. The 1 and this, which turns into a -1, cancel. This is negative x to the 4th minus 2x squared. We're going to power rule this. Which means that that integral thing is not there anymore. X squared over 2 plus 2x to the 3/2 over 3/2 minus x to the 5th over 5 minus 2x cubed over 3. We want to plug in 1 and 0, so we don't actually need to plug in 0, we just need to plug in 1, which shouldn't be too bad. And we get 29/30 for our answer. with pi. 29/30 pi. Last problem, volume with washers, but we're not rotating around the x-axis, we're rotating around a different axis, which at some point is going to make us subtract 2 from both of these, but not until after we graph it. We have a line at y equals -3, that's a boundary. We have this square root function that starts at -3 right here. We have a boundary at x equals 1. We're going to make this be an itty bitty region that we are going to shade in right here. Now we are rotating this around y equals 2. And so that means that we're not going to do top minus bottom, because we're really actually trying to do outside, which this is farther out from where we're rotating, minus the inside. And so we want to do the -3 part of this first, although we want to subtract 2 from both of these as well. So this is pi. It's between 0 and 1. We want to do -3 minus 2, which is -5 first, because it's on the outside. Since it's underneath where we're rotating, we want to do bottom minus top instead of top minus bottom. And then we want to do square root of x minus 5 squared. We want to simplify, work out, all that stuff. This is 25 minus x minus 10 square roots of x plus 25. We're going to distribute the negative, which when I did this on our previous review, because it is the same problem, I did not distribute a negative and got a negative answer and then got confused about why I got a negative answer. Yeah, but it's whatever. So you change the signs of the second part and cancel out the 25s. Remember that this is 10x to the 1/2, and we're going to power rule. So I don't need that anymore. This is -x squared over 2 plus 10x to the 3/2 over 3/2. We're plugging in 1 and 0. So we really just need to plug in the 1, and that will give us 37/6 pi. So that's our answer, and that's the whole review. That really is a basic gist of what we've done this semester. And so I hope you've enjoyed this video and have a good time